In this video I'm going to show how we can use lambda expressions, and I'm going to do that in combination with the ForEach method. Let's start by creating a list of strings. So here is a list of strings and we call this instruments, and this is a new array list, and we're going to fill the new array list with a number of instruments. First we need a few import statements from Java util, and at this point I'm going to use the class collections. Add all, add a number of instruments to our list. And you can see we have a bongo, a bugle, cello, chime, flute, piano, taiko, and a viola. At this point I'm going to print the list. So I say sysout, control spacebar, and we make a label, for example instruments, and we're going to print the instruments based on its toString method. Let's see how this is looking like when we run the program. And you can see it prints all my instruments, comma separated within brackets. Now I might want a different way of printing them. Maybe I would like to have my rectangular brackets around each of my elements. Traditionally we would use a for each loop, so I might do something like this: for each string element in my instruments, and we're going to print them, sysout, the bracket and the element and the other bracket with a space. And afterwards, after all of my elements have been printed, I'm going to add a new line. And at this point I don't have the label, so here we had a label. I still would like to keep my label, so I'm going to use that as well. And because the label should be in the same line, we're removing the print line. Let's see how this looks like. So I'm going to run my code. And here you can see that all my elements have been printed one below the other. I forgot to remove the other ln right here. Let's run it one more time. And at this point I can see we have the instruments. This time the rectangular brackets are around each of the individual instruments. That works. However, we can exchange that for each loop with the for each method. I'm going to show you where the for each method comes from. So here I have a list, and a list is a collection. So I opened up the API for the interface collection, and when you look at collection, it tells you right here that the interface collection extends iterable. That means the collection interface has all the methods from the iterable interface. We're going to have a closer look at iterable. Now here I can see in my iterable interface that iterable has a for each method. It performs the given action for each element of the iterable until all elements have been processed or the action throws an exception. Let's see what this action needs to be. So here I have one parameter, its action. It needs to be a consumer. Let's have a closer look. What is a consumer? And when I have a look here, I can see a consumer is an interface, and a consumer has a method that accepts a given type and returns nothing. So we can use any method that takes a specific type, the type of the elements in my list, does something, maybe rings a bell, maybe prints it out, maybe assigns it to another collection, does something, whatever it does, but it does not return a value. That's important because it has to be void. I say, well, that's great. We don't need to return a value because we're printing anyhow. So I'm going to exchange the for each loop with instruments, and here for each, that's the method. Notice for each, and it tells me here again needs to be a consumer, which is fine. So we have the for each method, and my action is going to be the following. We are going to provide piece by piece the elements from our list. We had a name already for them before. We called them EL, like element. We can use the same name. I could have used X or another name as well, but EL seems a nice clear name. What are we doing with it? We're printing it. So I'm doing the exact same thing I've always done. So here is my element, and here is the statement or the expression that should be executed for each of those elements. Here it is an expression, and in that context was a statement. I still do need my label because that is nice for clarity, and I still want to close off by advancing to the next line. So here I'm going to advance to the next line, and when I run my code, I can see it does the exact same thing. I can use either the for each loop, or we can use the for each method with the lambda expression. Now it's your turn. What I would like you to do is the following. I would like you to print another lambda expression. However, this time it should print instruments as the label, and then it should print all the elements, still in rectangular brackets, but each of the elements is in all lowercase. Pause the video. Give yourself a moment. When you are done, press continue. You can see I was doing the exact same thing I did before, except I was calling on each of my elements the to lowercase method. I can do that because the element is a string. So here in the for each loop we were very explicit about it. Now in my lambda expression we don't have to mention that because we all know we have a list of strings. So I can call the to lowercase method on them. Let's run the code. And this time you can see all my individual elements are in lowercase. I have one more challenge for you. I would like you to write yet another lambda expression, and this time it should print each of the instruments twice, and they should be separated by a vertical bar. And once we printed the instrument twice, there's a single space, and we print the next instrument twice, separated by a vertical bar. Again, give yourself a moment to try it. Pause the video. When you're ready, press continue. Here is something to compare it with. What I did this time is I print by element, a vertical bar, the element again, and then a space to separate it from the next element. Let's see what happens when we run the code. You can see we have bongo, vertical bar bongo, etc. all the way down to viola. So far, we have demonstrated how we can use for each and lambda expressions in order to access the elements from a list of strings and how to display them in different ways. What I would like to do next is the following. I would like to create both a list and a set, this time of numbers, and use for each in that context. I'm going to refactor the code a little bit. So we're going to select everything that is in the body of our main method. I right click, refactor, extract a method, and this method is called demo for each with list of strings. So here We have a list of strings. At this point, I can easily comment out all this functionality, but also quite as easily bring it back when I want to see it again. For now, I move on and I'm going to create a new list. My new list has numbers, or I call it Numberless. This is a new array list. Whoops, this is one S too many. Next, we're going to initialize the list with 15 random one-digit numbers. That's what I would like you to do. Pause the video. When you're done, press continue. Here is something to compare it with. I was creating a random number between 0 and 9 inclusive. I was adding it to my number list, and I was doing this 15 times. Now I'm going to print my numbers. Let's print them side by side, separated by a space, using a lambda expression. Pause the video. Give yourself a moment. When you're ready, press continue. Let's run the code. And here you can see we have a number list. If I run it again, those numbers should be different because they're random. Up until now, we always use the ForEach method to print something, but we can do other things as well. So when I roll over, I can remind myself that all we need to do is provide a consumer. So we can do anything that takes an element and does not return a value. So we could, for example, take all the elements, use them to populate a second list. And so here I'm going to create a second list. It's going to be another list of integers. I call it Numberless 2. And I'm going to use my original list with the ForEach. And this time we're going to use the n, and we're going to multiply it with 10 and add it to the new list. At this point I'm going to print my new list. To speed myself up, I just use the toString method. So here is Numberless 2. We're going to run the code. And you can see my Numberless 2 has the same elements but 10 times bigger. At the beginning of this video, I pointed out that all data structures that implement the interface collection have a method ForEach. So far we've used it with lists only. So let's create a set and use it with a set. Here is a set of numbers. I'm going to call it number set. And we're going to instantiate a new hash set. We're going to need an import statement from Java util. And just like list is an interface that extends collection, so is set. Because we can't instantiate interfaces, we needed an ArrayList, a class that implements the list. And here we need a class that implements the interface set. So the next step is we're going to populate the set. We want to add all the elements from my second list. And the way I can do that is by using the method addAll. So I have number set addAll. Now notice there is an addAll method in class collections, but this is not it. This is an addAll method from interface collection. It's a little bit different. Let's look at those. Here I have interface collection. When I check out the different methods, I can see there's a method addAll, which means we can add all the elements from an existing collection to this collection. So we can add all the elements from my second list to my set. Now in comparison, if I go to my class collections and my addAll method, I have to provide the collection, and then I can add the elements either individually or as an array. So slightly different, but it's the same name because it's the same functionality. So here we are, add all. We're adding all the elements from my number list too. I'm going to print out my set, and to speed myself up, I give myself a bit of a starter here. This is now my number set, and we are providing the number set when we print it. Let's see how this looks like. Notice that my number set has fewer items. We were adding all the elements from the list, but it does not include as many elements as the list. Number set includes all the unique elements, which means all the duplicates were removed. Here I'm going to take a moment to point out the differences between a list and a set. In a list, each element has a position, so we can use an index and say what is the second element or what is the last element. And we can check is one element before or after another element. Not so with sets. Typically, elements in a set do not have a position, but sets have no duplicates. So if I keep adding the same element over and over again, it doesn't make my set bigger. It just ensures the element is there. So that's something to be aware of in regard to sets. Now we printed the set using the toString method. I can add a few spaces here to make it a little easier to read in the output. And now I'm going to print it one more time using a lambda expression to print the elements separated by space only. As a matter of fact, I would like you to do that. Pause the video. When you're done, press continue. And here is something to compare it with. I'm printing my label, I'm using the ForEach method and my lambda expression to print the individual elements, and I advance to the next line. Let's run the code. So at this point I can see my number set, same numbers that have been in the set, just slightly differently formatted. The last thing I want to do is refactor to make my code a little bit nicer. So I'm going to use all the content of my main method except for the first commented out method call. I right click, refactor, extract a method. I'm going to call this method demo ForEach with list and set. So here we have two methods that we might want to comment out every so often, which results in a warning. Warnings are not ideal, so I roll over it and I say let's just suppress the warning. Usually, caveat, we don't suppress warnings. Usually we want to make sure that we fix the code. In this particular situations, it is by intention, so we're going to suppress the warning. Now for good measure, I added a doc comment to the public class. This is a best practice, and we can remove additional empty lines. This was it for today.